This is our first example where we have a manipulated variable with two override controllers. And so you can have any n number of override controllers. So this is a good example to see the behavior when you have multiple override controllers. So the purpose of this heater here is to increase the temperature of our process steam, which is measured here. And so then we have a temperature controller that goes to this flow controller, which controls the amount of fuel. And then with a heater or furnace or a boiler, anything that you have a combustion reaction, a fuel air mixture in order to have heat transfer into some sort of process fluid, you would have this be ratio controlled, fuel and air together, to make sure that you have the right lean, all right, not lean, actually rich in oxygen mixture for safety reasons. So going back to this example, temperature of the steam is the normal operating control variable, and then we have two abnormal condition control variables. One being the pressure of the fuel, and second would be the stack temperature, the exhaust gas temperature. The stack temperature as well as the fuel pressure cannot be too high. If fuel pressure is too high, then a stable flame might be sustained within the heater. And if a too high of a stack or tube temperature occurs within this heater, then the internals of the heater can be damaged. Therefore, high set point override controllers for both stack temperature here and fuel pressure here must be implemented. So go here, our manipulated variables fuel flow. Actually, it's I guess more the fuel control output, but all three of these controllers are overriding to send a set point to fuel flow. So our manipulated variable is fuel flow in this case. So if I increase the amount of fuel going to my heater, I know everything within my heater is gonna be hotter, and my fuel pressure is gonna increase. I have more fuel, as well as my stack temperature is gonna increase, as well as my steam is gonna increase. Since both stack temperature and fuel pressure are high set point override controllers with positive gain, then a low select function block needs to be used in this example. As you can see in this example, we have four blue dotted lines. The first blue dotted line is set point for the tank level controller, which is controlled by the fuel control valve. The second blue dotted line is set point for the override controller for fuel pressure. The third blue dotted line is the set point for the override controller for stack temperature. And the fourth blue line is the initial value for fuel flow. And each vertical red line is a different sampling period. Suppose that the fuel pressure increases above its set point at time 2. And so if fuel pressure is too high, our fuel pressure override controller will supersede the steam temperature controller, which will decrease fuel flow, which will decrease stack temperature and decrease steam temperature, and fuel flow will be adjusted continually until this fuel pressure reaches back to its override set point. So thank you for watching, and I hope you all have a good rest of y'all's day.